All right, guys, it is the 28th of January, 2021. We are in day 2 of our acid-base chemistry lecture. And we're going to go over a few of the homeworks. The Alveolar Equation, I gave you guys, it was in the lecture about the normal values and doing class yesterday. So you can write these normal values down if you didn't see it or you forgot. The normal values for the alveolar equation is what you would use unless they give you some parameters. Like the homework, they gave you what they want you to put. If whatever they didn't give you, you use the normal values. Okay? We said that the PB, which is P bar, you may see P bar, PB, it's the same thing, guys. 760 is the normal. For number one, they said 747. So you use what they give you, okay? But if they didn't give you the P bar, you use 760, okay? The pressure of water, which is pH2O, the normal is 47 millimeters of mercury, okay? FiO2 could be whatever. If it's room air, it's 21%, unless they give you that they're on oxygen. If they said they own 40%, then it's 40%. You put 0.40, okay? Or 0.4. And then the respiratory quotient, of course, is 0.8, 0.8. And the CO2, what's the normal CO2? 40. Right smack down the middle is 40, okay? And so those are the normals for the alveolar equation. Those are the normals, okay? Then you take what you know and you start working the problems. Whatever they tell you and whatever they give you in the problem, that's what you use, okay? So evidently in some of these barometric pressures, they gave you a lot of different barometric pressures. You use what they give you, okay? And that's how that works. Now, somebody said, I think Michael found in a book that it says something about times, the respiratory quotient was times 1.5. I don't know what that's all about. Just use the 0.8 like you've learned. 0.8. I don't know if they're trying to say you can do either one, but it comes out about 10 more if you use that. So that's not the one we're using. The respiratory quotient is 0.8. Okay, 0.8. And I gave you the formula for the alveolar equation. That does not change. That's the formula. Okay. All right. So let me write it up here on the board. E big A O2 equals FiO2 times the P bar minus the pressure of water minus the P little a CO2 divided by the respiratory quotient. That is the formula. Your normals. P bar is 760 millimeters of mercury. Your pH2O is 47 millimeters of mercury. Your PaCO2 is 40 millimeters of mercury. And your RQ is 0.8. These are your normals for the pressure of arterial O2. Those are your normals. You use these normals unless they give you another value. Okay? Unless they give you another value. So for instance, I'm going to do number one, and then I'll do one that somebody wants to see done. Okay? Number one says, this patient has a PB of 747, a CO2 of 36, and a FiO2 of 21. So I just use what they give me. All right, so P big AO2 is, FiO2 is 0.21 times the P bar is 747. They didn't give me the pressure of water, so I use the normal, which is 47 minus the PaCO2, okay, is 36 divided by, they don't give you the RQ, so you use 0.8. All right. So 747 minus 47 is 700 times 0.21 minus 36 divided by 0.8 is 45. All right. 0.21 times 700 equals 147. So 147 minus 45. That gives us a P big AO2 of what?
102.
102 millimeters of mercury. That's number one.
Worksheet that you gave us for the quiz, I believe it was number 4 or maybe 5, because you also gave us the answers, but when I worked it out, I got a 2-point difference in one of the answers.
Okay, we'll look at it. We're working on this worksheet right here.
Oh, okay.
All right, so that was number one on the homework. Number one was 102 millimeters of mercury. 102 millimeters of mercury. All right. All right, was it another one that you guys needed to see? I'll move a little bit closer. All right, was there another somebody need to see, or we can move on to the next sheet? Can y'all hear me?
Yes.
Number 9. Oh, okay. Okay. But if you don't have one, that's fine. I mean, you know, it's fine. It's not that hard. Any others? All right. What did you say?
I had said number 9.
Number 9? Okay. Number 9. All right. So in this one, they give me the P bar, the CO2, the FiO2, and the respiratory quotient. Okay? On number 9. All right. So FiO2 in number 9 is 26%. So 0.26. They're on 26% oxygen. All right. Times the P bar is 745. Minus the water pressure. They don't give us the water pressure, so we use 47. All right, minus CO2 in this one is 41, divided by the RQ being 1.0. This is how you would work it out. All right. What's my calculator? All right, so 745 minus 47 again is 102. Oh no, that 745.
698.
98, yeah. 98 times 0.26 minus 41 divided by 1, of course, is 41. All right, so now 0.26 times 98 is 25.
How is it 98? It's 698.
It's 698.
Oh, okay. Okay. I'm just going by what you're telling me. 698, my bad. I thought that was a little low number. 26 minus 41. All right, here we go. 698 times
181.48.
26. Good. 181 point, let's just say 0.5. Okay. Minus 41. So minus 41, it's about 140. About 140 millimeters of mercury.
The one I was talking about was number 4.
Okay.
Yeah, the one there was 304, but I got 306.5.
That's fine. It just depends on how far you use the decimal. So that was number 9. So was that Courtney?
Oh, no, sir.
Who was that needed that? Who asked for number 9?
Brittany.
Oh, did you understand what you did now?
Yes, sir.
Okay.
Thank you.
You're welcome. All right, so another other one is number 4. Number 4 says FiO2 of 50%. So 0.5 times P-bar of 750 minus the water pressure of 47 minus CO2 is 36 divided by, they don't give us a respiratory quotient, so we use 0.8. All right. All right, 750 minus 47 is 703 times 0.5 minus 36 divided by 0.8 is 45. Then you have 0.5 times 703, and that is 351. Yeah, it is. Yeah, 351 point what? 0.5 minus 45 gives you what? So about 306.5. You might have got a couple of decimals off, it depending on how far you went with this decimal. Okay, that doesn't. It's not going to be any answer that was 2 decimal tenths off or nothing like that. Overthink. All right, 306.5. P big AO2 of 306.5 millimeters of mercury. Now, I told you guys what is the normal PaO2? P big AO2. 100. So why is this number so high? What's the ultimate reason why this number, which is what this is, so high?
Because they've added in oxygen.
Good, because they own 50% oxygen. They're not on room air, right? You adding more oxygen. So if I'm adding more oxygen, it's going to be more oxygen pressure in my alveoli. Okay. possible. No, not necessarily, because your CO2 is about still normal. Okay, it could be still high. I told you, CO2 and oxygenation are two different things. CO2 and oxygenation, two different things. So it doesn't necessarily mean you can still have a low CO2 or you can have a high CO2. It just depends. Because if I'm giving oxygen, no matter how, you do have to ventilate to get it in. But just think, if you ventilate 2 times, all that oxygen's coming in. So you have reservoirs in your oropharynx and your nasopharynx, right? You're going to learn when we get to oxygen therapy, all this is a reservoir. All this is a reservoir. So if you're barely breathing, all the oxygen that you're getting is just building up. As soon as you inhale, that's pure oxygen going down. Okay, so that can still make your PbAO2 go up, but not necessarily. Your CO2 can still be high because you're barely breathing. Okay. All right. That was number 4. Is that it? That's all it is, guys. Like I said, it looks bigger. The problem looks more than it is. It looks nice. You can put it on your dresser, and everybody says, "Ooh, who's working that out?" But you want to learn that the P-bar and water pressure rarely change. So that's usually 713 right there. And then so you really just have to multiply by the FO2 and subtract what this is over here, and you got it. Okay. But today we're going to talk about now is the Aa gradient. Aa gradient. The difference between the alveolar oxygen pressure and the arterial oxygen pressure, right? When we inhale and we get this alveolar oxygen tension in our lungs, it should readily transfer into the arterial blood, right? The capillary is right there, ready to gas exchange it, right? But sometimes it doesn't get across for whatever reason, all right? And there's a gap between the two. That's called an Aa gradient. We're going to talk about the pressure of alveolar minus O2. The pressure of the alveolar minus the arterial O2. That's called the Aa gradient. Kind of the difference between the two. It's kind of like a secret. If I told you something and then you went and told somebody else something different, there's a difference between the two. If I told you and you turn around and told somebody else, it should have been damn near the same, right? But because you got a problem in your head or whatever your issue is, you changed it. And so now there's a difference between what I said and what you told somebody else. So it should be almost the same. When this alveoli, right? When this alveoli has, just let's say, it has 100 millimeters of mercury of O2, right? That's what it should be about. The pressure should be about 100 millimeters of mercury. Well, if that's the case, but this arterial blood that's around it, right? Let's just say it is only 80 millimeters of mercury. What's the difference? What's the Aa gradient?
20.
Good. So the Aa gradient would be P big A minus little a O2 would be 20 millimeters of mercury. There's a difference between the two. It should have been almost the same, about 10 or 15 away. That's it. But it's 20. Sometimes it's 40 or 60 right here. It's like, damn, it's 100% in here. Why is it not getting into my blood? Okay, because you might have some alveolar issues, right? What is the main reason or the main issue in an alveoli that would keep a ventilated alveoli from getting the blood, the oxygen into the blood? That diffusion, huh? Not the perfusion. You got the perfusion and you got the ventilation, but what will be a reason why that oxygen just didn't get across?
Shunt.
No, not a shunt. Listen to me, guys. You don't have dead space or a shunt. You got blood and you have ventilation, so that's not the reason. there's something in particular with that alveoli that would be, what would be keeping the gas from getting across this membrane?
Would it be an alveolar defect? Like a defect in
Alveolar
the wall?
defect of what, and what cell is that?
The type 1?
There you go. No, type 2 cells are clear cells. The type 1 cell, if your type 1 cells are responsible for gas diffusion. And so if they're jacked up or diseased or fibrotic, then that gas cannot get through that type 1 membrane. And so you got the oxygen in here and you got plenty of blood, but why is it not transferring? See, that's when we see our Aaa gradient. And diseased lungs will always have a greater Aaa gradient. Okay? That lets me know your lungs are diseased. Okay? All right. Let's take some notes on the Aaa gradient and move on. Because we're going to learn what the normal Aaa gradient is. Because it should be a little bit. It's not going to be perfect. But there is a little bit of gap, but not a big gap. Okay? Because those gaps can tell us if there's a shunt. Okay? If the gap gets big enough, then that's starting to be a shunt. Because that means the blood is there, right? But it ain't picking up what? If the blood came but was not able to pick up the oxygen, that's a what? That's a shunt. Okay, that's a shunt. What I was saying is you don't have that. I wanted you to see that the alveoli is open and you got perfusion, but it could be something wrong with the type 1 cell. And if that's the case, it's just like the alveoli was closed. Might as well. If it can't get out, you might as well close, right? And so it still is considered a shunt, okay? Because the blood is there, it's not picking up. The alveoli is open. You said, well, Mr. Carter, you said if the alveoli is open, it's a normal VQ. It can be a normal VQ, but still be a shunt if there's an alveolar defect, okay? If there's a defect in that wall and it just can't get through, okay? Mm-hmm. It's different. Mm-hmm. Mm-hmm. All right, so let me share my screen. All right. Soon we're gonna get into this, the ABGs. Haven't gotten building my way up to that, but that's what's gonna be the biggest part of this whole thing. All right, so here goes the Aaa gradient right here. Alveolar arterial oxygen difference. Okay. What's that saying? It's just simply saying that the measurement of the pressure between, or the pressure difference between the alveoli and the arterial blood. That's what the Aaa gradient is, or the Aaa difference is. Okay. Now, in normal lungs, it's in normal healthy lungs, the oxygen is readily transferred from the alveoli to the blood. And there's only a small amount of PO2 difference, pressure, because Aaa gradient is still pressure. You got pressure inside the alveoli, pressure of oxygen inside the arterial. And the difference between those two pressures itself is a pressure, okay? So we're talking about pressure of oxygen in this, what we're talking about, okay? So in normal lungs, oxygen, man, it just readily goes back and forth, and a little bit doesn't, it's a small amount, all right? But this is important. Diseased lungs will often have a larger gradient because of diffusion defects. So whoever told me that, whoever said that first, that excellent. You're exactly right. Diffusion defects. That's why you have to be able to go back to your pulmonary anatomy, your cardiac anatomy. All this stuff works together, guys. It works together. All right. Now, it has been used to estimate the percent of shunt. You can use it to estimate shunt by this key right here, which is important. Make sure you write this down. On 100% FiO2, every 50 millimeter mercury difference in the gradient approximates a 2% shunt. This is only, you can only do this if they're on 100% oxygen. They have gotten sick enough to the point where you have them on 100% FiO2, okay? And they still have a difference, okay? It's like you pumping them with pure oxygen and it's still not getting across. That is how they can estimate how bad your shunt is, okay? Because for every 50 millimeter mercury difference in the Aa gradient, it approximates a 2% shunt. For every 50 millimeter mercury difference in the Aa gradient will approximate a 2% shunt. This is why they're on 100%. You can't do this if they're on anything less than 100%. Okay? An increase in the Pa gradient is strictly an indication of respiratory defects in oxygenation abilities. Most respiratory dysfunctions that produce hypoxemia are accompanied by an increase in the Aa gradient. So all of your pulmonary diseases is going to have a greater Aa gradient than normal lungs. And the normal value is about 10 to 15 millimeters of mercury. Normal Aa gradient is about 10 to 15 millimeters of mercury. What is the normal Aa gradient? 10 to 15 millimeters of mercury. All right, so let's see if we can estimate Mr. Smith's shunt. All right, see if we can estimate Mr. Smith's shunt. All right, I want you to work this out. I'm going to give you some parameters. He's on a FiO2 of 100%, and his PaCO2 is 52 millimeters of mercury. I want to know what, let me also give you his P-little-a-O2. His P-little-a-O2 is 60 millimeters of mercury. My question is, what is his P, big A, little a, O2, and what percent shunt does he have? These are his values. And I want you to work it out and tell me what his A gradient is and what percent shunt is he experiencing. And I'll work it out too. I'll give you some time. Put it in you can put it in the chat as two things. I want to know first his Aa gradient amount, and make sure you use millimeters of mercury in your answer. Don't just start throwing numbers up. Get into the habit of using the correct suffixes or units of measure, and then tell me the percent shunt that he's facing. Remember, we said for every 50 millimeter mercury. Hold on, it's telling me to close some of my application, so I'm gonna get my big head out the way in a minute. Hold on. All right. For every 50 millimeter difference in the Aa gradient equals a 2% shunt. So I'll write that down so you can see it. Every 50 millimeter mercury difference in the P big A little a O2 equals a 2% shunt. Can y'all see that? So it's a couple of steps. Just take your time, one thing at a time. It ain't nothing to it. First, solve the P big AO2, our alveolar equation, with the values I gave you. Whatever I didn't give you, use the normal value over to the side. Okay? Figure that out first. And then you want to look at this right here. This is the P little AO2 right here. So you subtract that from your answer to get your difference. Okay? Then you take that number and find out what percent shunt is that. While you understand that every 50 millimeter mercury difference in the Aa gradient equals a 2% shunt. Put it in the chat. Now you're getting into therapy. Chat disabled. Shouldn't be.
Mine's showing the same thing.
Let me see.
That's what mine's saying too.
All right, try it now. Say disable now? Okay. Can you look at it again, man? All right, charisma. Your first number is the AA. Your first number is the alveolar air equation. You didn't do the gradient. You got to do the AA gradient. That's what I'm looking for. So you're right with the shunt. You did it right with the shunt, pretty much. But your AA gradient, your alveolar air equation is the number you gave the first one. That's the alveolar air equation number. You got to take that number and subtract the P little a O2 because it's big A minus the little a, and that's the gradient. Good, Stephanie. Damn, what happened? Okay. Good, Stephanie. That's excellent.
Okay, so you said subtract the PaO2 from the P big A O2.
Take the P big A O2 and you subtract the P little a O2. That's the AA gradient.
Okay, gotcha.
Big A minus little a. And that's going to be a pressure in itself. So the first number that you gave is right, but it's for the P big A O2. I need to know the gradient. Michael, and you did the same thing with your AA gradient. You didn't do the AA gradient. You need to do the AA gradient. Okay, Charisma, then that's the AA gradient, and then you had the shunt part right. So that's cool. Make sure y'all send your messages just to me, because other people might not know it, and they just pick what you pick, and that don't help me. Courtney, that's the AA gradient. Good. Now, what's the shunt, Courtney? Good. That's good, Courtney. Y'all got it. All right, so Kenya, let's do it together. Yeah, but let's look at it together. All right, here we go. All right, Kenya. First of all, let's find the alveolar equation number. Okay, so P big A O2. What's the FiO2? So how do I write that? 1. 1 times, what's the barometric pressure? P bar.
760.
Alveolar equation. So what's the P bar? Kenya? 760. All right, Kenya, what's the normal water pressure? 47. Because I didn't give it to you in the problem, so you use the normal. Okay? 47. Minus, what is the P little a CO2 in what I gave you? 52, right? 52. Now, if I didn't give you this, you would use what? 40. All right. Now, what's the RQ? Did I give you a RQ? No. So what you use? 0.8. All right, 0.8. Now, let's work it out. 760 minus 47, Kenya, is what? 713, right, times 1, minus, what is 52 divided by 0.8, Kenya? 65. All right, 713 minus 65 is what, Kenya? 648. All right, 648? Okay. So the P big A O2 is 648 millimeters of mercury. Okay? Now, the AA gradient, you have to take the big A and subtract the little a from it. So for this one, you would say 648 minus what, Kenya? The AA gradient is this right here. P big A minus the little a O2. All right, I gave you a P little a O2 right here. So that's 648, which is the big A, minus what? 60, which is the little a. So this is the big A here, and this is the little a. Okay? So 648 minus 60, Kenya, is what? 588. So the AA gradient is 588, right? Okay, good. So that's the AA gradient, what I asked for. I said, what's the AA gradient and what's the shunt? Okay. Now, millimeters of mercury. So now I said every 50 millimeter mercury of difference. The difference is 588 millimeters of mercury. So for every 50 is a 2% shunt. All right, so find this out, guys. You have to divide this By what? Mm-mm. You're trying to see how many 50s are in here.
50.
50. Because every 50 is a 2% shunt. 50 more, 2% shunt, right? So if the difference was 100, that'd be a 4% shunt. If the difference was 50, that's a 1%. I mean, if the difference was 50, that'd be a 2% shunt. If the difference was 100, 4% shunt. If the difference was 150, 6% shunt. See that? Every 50 goes up 2 more percent. So how many 50s, Kenya, are in 588? No, you tell me. How many 50s? There you go. Don't guess. That's all right, man. So the percent shunt is 11.7 or 12%. See that? So 12% of his lungs are shunting. Okay? 12% of his lungs are experiencing shunt. That's how you find that, guys. See that? Seem like a lot, but once you do them a couple of times, that's it. That's it. Okay? That is the Aa gradient. That's talking about the pressure of alveolar oxygen tension. Okay? The alveolar oxygen, how much pressure is oxygen exerting inside the alveoli? And is that oxygen pressure transferring into the arterial pressure, right? Is that alveolar making it to the blood, right? If it's not making it, something's wrong. Okay, something's wrong. If the blood is there and the air is there, but it's still not getting through, there is an alveolar defect, which, like you said, the type 1 cells. Okay? Yes, it is. FiO2 is whatever, however much oxygen you're breathing in right now. That's the FiO2. Yeah, if I say room air. The room air value is 21%. And that's what they're going to say. Patient is on room air. Interpret this ABG, patient on room air. Or tell me, is he oxygenating if he's on room air? So you just using room air is 21%, right? Question? Defect? Yeah, I said if the oxygen is inside the alveoli, but it ain't getting through to the blood, then there's a type 1 cell defect, because the type 1 cell of the alveoli is responsible for gas diffusion. So we exchanging, right? The alveoli tells the blood, you give me the CO2, I'll give you the oxygen, right? But if I'm trying to hand you the oxygen through burglar bars, right? It should be able to just hand it out the window. But if I'm running into a screen, I can't get it to you, right? I got to push it through the screen in order for you to get a little bit of it, right? There's a defect. It should be nothing but freely spaced. I should be to hand it to you, right? And you hand me back yours. But if there is a screen there or some type of defect in the alveoli, that will keep it from getting across. And that's going to show up as a Aa gradient, a difference. And the normal Aa gradient, guys, is 10 to 15. So you're going to have be able to solve the alveolar equation and tell me the Aa gradient, and then tell me, is it normal or not, right? We're going to start doing case studies now that you've learned a little bit, where I can tell you Mr. Johnson's case study. He came in with SOB, right? He was diaphoretic. He was febrile with this temperature. What is his temperature in Celsius? What is his blood pressure? You're going to learn what is his ABG, right? Is he experiencing hypoxemia because of his hemoglobin? I'm going to give you hemoglobin, CBC numbers, all that kind of stuff, right? And you got to be able to take all of that information and pick out what you need to answer my questions, because that's how you're going to see a patient. He's not going to be able to say, yeah, my Aa gradient bar is acting up, right? My Aa gradient is about 30 today. Can you do something for me? He don't know that. He's going to give you blood. We're going to go in and get arterial blood. The nurse is going to draw venous blood, and we're going to compare our numbers. And also how he looking. Is he using his accessory muscles? Is he working hard to breathe? Those type of things is what you got to chart, right? And know what's going on, so I'll know where to start when I'm trying to fix them. Okay. All right. So it's 50 out, 55 after, or really 52. I think my watch is a little fast. It's 52 after. So let's come back about 7 after. 207. Gonna take a break to 207, and we're going to continue on with CO2 transport and ABGs. I'm gonna give you the values of your ABGs. Start teaching you how to read an arterial blood gas. Wasn't recording. Okay. All right, I'm recording again. Here go the values for ABGs. We're about to get started to show. I'm gonna put it on the screen just for a hot second for those who may be watching it later. These are the normal values for arterial blood gases. These are the ranges right here. And this, of course, will be the absolute or perfect number. Okay? These are it right here. And I'm about to show you on the board what constitutes acid, what constitutes alkalosis, and whether it's respiratory issue or metabolic issue. All right, we've said that CO2 is ventilation, right? And what problem is CO2? CO2 is ventilation. It is a what? Huh?
An acid.
Gas. Yeah, acid. It is what?
Alkaline.
Respiratory.
No, not alkaline. CO2, aka acid, aka ventilation, aka respiratory. So if it's a CO2 problem, it's a respiratory problem, right? Then I said bicarb is aka metabolic, aka base, aka alkalosis, right? Alkaline. If it's a bicarb problem, it's a metabolic issue. Okay? Keep that in mind, because when we find out the patient is in acidosis, well, who caused the acidosis? Did respiratory cause it, or did Mr. Metabolic cause it? See? And you got to know, well, it's because of CO2 doing something wrong, then it's a respiratory acidosis or a respiratory alkalosis, okay? You're about to learn that now. So get your numbers out. The whole goal of what we're doing, guys, is to try to modify or keep pH in the middle. Okay? That's what we're trying to do. Now, 7.4 is perfect pH. The range is, what's the range for pH? Okay, so 7.35, 7.36, 7.37, 7.38, 7.39, and 7.4 would be perfect, right? Now we go the other way. 7.41, 7.42, 7.43, 7.44, and 7.45. All of this is normal what? Normal pH. All that is normal range. But the absolute smack daddy right in the middle perfect pH is 7.4. Perfect. All right. Now, what you need to know, get all of that. Write this down. pH can lean. Okay. pH can lean toward acid, or she can lean toward alkalosis, but still be in normal range. Okay. She can still be in normal range, but she can lean either way. So pH is the only one that can lean. The rest of the ABG parameters are either that or they ain't. If they're not in normal range, then they're out of normal range. Okay. One away is out. They don't lean. pH is the only one that can lean. So which way are we leaning? Okay, well, pH my red. A pH this way. This way is acidosis. Going that way. And going the other way is what? Alkalosis. Going this way is alkalosis. And what we're trying to do is, it's like a balancing beam. Okay, pH is in the middle, and we have a acid base. We're trying to balance pH out. Okay, we balance on this side with PaCO2, which is CO2 is a what? Acid. It is an acid. Okay, and on this side is HCO3, which is a base, alkaline. Alkaline. Okay, or you could say base, right? Alkaline or base. And CO2 is acid. We also said it is respiratory and ventilation. Okay, bicarb is alkaline, base, and what? Huh? Bicarb is alkaline,
Metabolic.
base, metabolic. See that? That's why I told you those AKAs a long time ago. Told you to study them and learn them because you're going to be using them when you get to ABGs. So if you know somebody who's not here, you need to call them because this is very important. All right, so the other parameters I gave you also do certain things, okay? They also do either way, right? One way is acid, one way is alkaline, okay? So pH, this is pH, right? So I'm gonna put it right here. This is pH, right? pH is 7.35 to 7.45, right? This way is what? Acidosis.
Acidosis.
Good. So less than 7.35 is acidosis, or even you're going to learn when I say 7.37, guys, is in normal range, but leaning what? What word?
Acidosis.
Acidosis. 7.38. It's in normal range, but it's still leaning which way?
Acidosis.
7.42. It's in normal range, but leaning which way?
Alkalosis.
See? pH is the only one can lean. All right? So this way is acid. And then this way is alkaline. The next one is PaCO2. 35 to 45 millimeters of mercury. Okay? Since CO2 is an acid, well then anything going this way is what? Greater than 45.
Alkaline.
Alkaline.
CO2 is an acid. If the CO2 builds up to greater than 45, what is that? Don't guess. Think about it. If you don't breathe, you start building up CO2.
Carbon
It'd be an
monoxide.
acid.
Acid, thank you. If you breathe, yeah, it's carbon dioxide, but what I'm saying is, if you're, remember we said CO2 is 35 to 45. If you hypoventilate, you're not going to blow off enough, and you're going to start building up CO2, and CO2 is a acid. So going this way is acidosis. All right, and if it's less than 35, it's now going into alkalosis. Yeah, they all want to go together, but don't say what, because they're opposite. So don't say, well, if it's going to right, anything going to the right is this and or the left. It's not that. You got to know the parameter. pH less than 35, 7.35 is acid. pH greater than 7.45 is going alkaline. Okay.
So the main thing is you need to know the ranges.
You know the ranges and which way they go. So CO2 is 35 to 45. Anything greater than 45, they're building up acid. That's acidosis. All right. If it's less than 35, they're blowing out too much of it. Blowing out too much of that acid. So now they're becoming alkaline. Okay. Now, HCO3 is bicarb. What's the normal bicarb? What's the range? 22 to 26 milliequivalents per liter. Now, bicarb is a base, right? It is a base, right? Alkaline is, bicarb is a base. So if you have a whole lot of bicarb, you're going what?
Alkaline.
Alkaline, because it is a base. It is alkaline. It is a base. So a whole lot of it is going to be alkalosis. And if you don't have enough of it, if it's less than 22, it's now becoming what? Acidosis. All right. This is not the oxygenation part. Right now, we're just focusing on the acid-base status. Okay. So recap. pH is in the middle at the top, right? Normal range for pH is 7.35 to 7.45. That is the normal range, okay? But you can think about anything greater than 7.45 is definitely alkalosis. Anything less than 7.35 is acidosis. Now, she can still be in the middle here and be in normal range, but leaning either acid or alkaline. These others cannot lean, okay? It's either normal or not. So a CO2 of 46 is acidosis. Okay, a CO2 of 44 is normal. Anything in between 35 and 45 is normal. It don't lean. Well, it's normal, but it's leaning. No. Only thing that leans is pH. All right, so a CO2 of 36 is normal. Okay? Bicarb, same thing. A bicarb of 22 to 26 is normal. Okay? If it's 27, it's alkalosis. If it's 21, it's acidosis. If it is 20, let's say 25, normal. 23, normal. Anything in between the range is normal. It does not lean. Okay? Only one that leans is pH.
Ms.
All right?
McCarthy.
Yes.
So if it was if her pH was 7.4, it would just be a normal, but even just 0.01 the other way would make it go one way or the other?
Yeah, well, if it was 7.41, it's still in normal range. It's just leaning alkaline.
Oh, okay, I see.
Leaning. So it's like tug of war. You got CO2 on one side and bicarb on the other side. They're pulling pH's arms, right? Two guys trying to vie for her affection, right? You got CO2 on one side, which is respiratory, pulling on her, and you got bicarb, which is metabolic, pulling on her, right? And you're trying, they're supposed to do that to keep her in the middle, right? We want her to be in the middle. But sometimes she goes off to one of the sides, and you have to find out who's causing her to do this, right? And that's how we determine what we have. All right, so let's look at it. So those are my normals. Let's make sure you understand what's what. Get my red out so I can match that in blue. All right, so this one happens to be acidosis. This is acidosis. And this is acidosis. All right. And all the alkaline, let's say in blue. Alkalosis. 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 All right. Now, if CO2 is causing the problem, then it's a what? Respiratory problem. If CO2 is causing the problem, it's a respiratory problem. It's either going to be a respiratory acidosis or respiratory alkalosis if he's causing the problem. If bicarb is causing the problem, then it's a metabolic problem. It's either metabolic acidosis or metabolic alkalosis. Okay? Throat dry. All right. Now, first, let's do a couple of preliminary to make sure everybody understands these values. So, for instance, knowing what you know, if I have a PaCO2 of 65, what is that?
Acidosis.
Acidosis. Good. What if I have a bicarb of 10?
Acidosis.
Acidosis.
Acidosis. Good. What if I have a CO2 of 10?
Alkalosis.
Alkalosis. Alkalosis. Okay. What if I have a CO2 of 36?
Normal.
What if I have a bicarb of 32?
Alkalosis.
Alkalosis. So think of it as the Rolaids, like base is like Rolaids, right? When you have stomach acid, you balance it out with a base, right? Which is Rolaids. You got pizza on this side or hot wings on this side. You got Rolaids on this side, okay? All right, trying to keep you in the middle. All right, so make sure you have this information because I can't keep this middle part in here because I'm going to be doing problems right here. I want you to show you how we read them, okay? Now, there are some rules to the game. In interpreting ABGs, there are some rules that you need to follow, which is on that whiteboard in the module. Rule number 1. What is pH doing?
Leaning.
No. I'm giving you the steps to interpret the ABG when I give you some values. When you get some values, you got to do this, follow these steps to be able to interpret the blood gas. Okay. The first thing you got to do is find out what is pH doing. Is she either acidosis or alkalosis, or is she normal? Okay. That's the first thing you got to find out, because whatever she's doing is what we in. She's the main player. Okay. There are 3 players in this, in the acid base. Player number 1 is pH. And then player number 2 is the one that's causing her to do what she's doing. So it can either be CO2 or bicarb, just depending on the values. Okay. And then you're going to learn that player number 3, you find out, is he trying to compensate for it or not? Okay. So we're going to first do just the basics. So what is pH doing? All right. Number 2 is who is causing her to do it. And when I say causing, I'm talking about whoever is causing the problem, and player number 2 is going to match what she is. Okay? Whoever's causing the problem is going to be matching what you see pH doing. Okay?
Oh, basically, acid or alkalosis.
Yeah, either acid or acidosis. You're going to find out what is pH doing. You say, okay, well, if you happen to say, okay, she's acid right now. Well, then who's causing her to be acid? You look at your other values and see which one of them are in acidosis or not. Oh, respiratory causing it. Or, oh, metabolic. So it's a metabolic acidosis, right? That's how you do this, the basics. Okay? Number 3. What is pH doing? Who's causing it to it? Okay. Is the third player trying to compensate? Now, in that one, if third player is in normal range, there is no compensation. If third player is not in normal range, there is compensation. So this goes with this. That's your steps. Yeah, you write them down, take a picture of it, because I'm gonna have to move that so I can put my other stuff up. First step, what is pH doing? Who's causing her to do it? Then you look at the third player. Is the third player trying to compensate? Yes or no? And these, before right now, today, for the first part, we're not going to worry about 3. We're just going to worry about 1 and 2. Okay? 1 and 2. Remember, we're only working on the basic acid-base relationship. I didn't put in your oxygenation yet. That's separate. But after you tell me what your acid-base status is, you're going to also have to tell me what the oxygenation status is. So you would say, for instance, oh, that's respiratory acidosis with hypoxemia, or no normal oxemia, right? Severe, moderate, or mild, moderate, or severe hypoxemia, right? You had that with sound. Remember that? The C with the line over it, that's with. So you'll tell me the acid base, and then with, and whatever the oxygenation status is. So we're going to learn the oxygenation status next. Let's get the acid base down pat first. Maria, The 47 we've been using in our equations is the pressure of water, not CO2. Mhm. pH is just the hydrogen ions in the blood. Remember when we talked about the dissociation curve? It said hydrogen ions, right? The hydrogen ions determine the pH of the blood. And there's a formula to find that. We'll learn that too in this section. You hear me, Maria? Maria, are you with me? I think she left. Maria asked the question. She said, it says that the PaCO2 is 35 to 45, but we have been using 47 for our equations. No, you haven't. 47 is the pressure of water, right? Barometric pressure minus the pressure of H2O. The pressure of H2O is 47. The pressure of carbon dioxide was 40 that you was using, all right? So, but she's not here to hear that, see? So, I mean, if she watches it later, she'll be able to do it. Or if she comes back. All right, so let's keep going. So let me erase this. Now we're going to get started. Here are a sample ABGs. You stick somebody and they're going to get these ABG results. pH of 7.1, a PaCO2 of 58 millimeters of mercury, and a bicarb of 24 milliequivalents per liter. And let's just say, I'm going to go ahead and put it in a PaO2 of 100 millimeters of mercury. All I want to know is the acid-base status, not the oxygenation right now. Acid-base status. So, by following the directions, charisma. Number 1 says, what is pH doing? So, charisma, what is pH doing?
In alkalosis.
7.1.
It's normal.
7.1.
Oh, wait a minute. Acidosis.
Acidosis. A pH of 7.1 is less than 0.35, so that's acidosis. Way in acidosis, okay? So, with that, we are in a what? She just said it. No, don't say what that yet. I ain't got to that point. We're in a what? Acidosis. So we are in a acidosis. We're in an acidosis, okay? Whatever pH is, that's what we are, okay? Now, we got to find the next. Number 2 said, who's causing the problem? Well, whoever's causing the problem is going to be the one that is going the same way pH is going, right? So, charisma. Let's look at all of our players first. What is CO2 doing right now, charisma?
It's in the acid base.
Okay, so it's acid. What is bicarb doing, charisma?
It's normal.
It's normal. So who's causing the problem, charisma?
The PaCO2.
CO2. So CO2 is what?
Respiratory.
So we are in a respiratory acidosis. That's it. For this first part, okay? We're in a respiratory acidosis. All right, let's look at another one.
You said that said that's whichever way it's leaning towards
No,
the pH.
whoever's causing the problem is the one that's matching what pH is doing. pH
So
was
they're
asked,
leaning towards that way.
no. Whoever is doing the same thing she's doing is the one causing the problem. She was acidosis, and then you looked at the other ones I gave you. The only one that was acid was CO2, so he's the one causing the problem.
Okay.
Okay. All right.
Okay, I get it now.
pH of 7.8, a CO2 of 40, and a bicarb of 32 milliequivalents per liter. All right, we'll just keep this 100 down here for PO2. All right, let me see who else is here. All right, Brittany, you with me?
Yes, sir.
All right, Brittany. First things first, what is pH doing, Brittany?
It's an alkalosis.
All right, so we are in a alkalosis. Let me scoot down some. We are in an alkalosis state. That's what we in. Whatever pH is in, that's what we in. Now we got to do number 2. Who's causing her to lean that way? One of them is pulling her that way. All right. So, Brittany, what is CO2 doing right now?
It's normal.
Normal. Okay, so CO2 is normal. What is bicarb doing, Brittany?
It's also no. It's alkalosis.
Alkalosis. So who causing the problem, Brittany?
HCO3.
Okay, which is a what kind of problem?
I got nerves. Oh God, I went blank.
Bicarb is a what type of problem? AKA,
Metabolic.
there you go. Metabolic. Metabolic alkalosis. We are in a metabolic alkalosis. All right.
Brittany, did you write down what he had just drew right before that? That help you.
Yeah, I got it though. Thank you.
All right. Now, mind you that respiratory, me and you, we cannot fix a metabolic issue. If it's a metabolic issue, it's for the nurses to take care of. They either gonna have to give them some bicarb or give them some fluids or something like that. We don't fix metabolic issues. We only fix respiratory issues.
So what are some metabolic?
Stuff like ketoacidosis from diabetes. If you've been throwing up for a long time and you're dehydrated and your metabolic status is very, very acidic, right? Things like that. We can't fix that. All right, good job. Metabolic alkalosis. All right, let's do another one. Scoot over a little bit.
Mr. McCarthy, before we go too far, the first one that we did was that respiratory acidosis.
I think so.
Yes,
Yeah.
it was acid. Respiratory.
Okay, thank you.
pH. So this time we got a pH of 7.4, a PaCO2 of 36, a bicarb of 25, and a PaO2 of 88. Okay. First things first. Let me see who's next. Who's iPhone? I just asked you to unmute. So whoever I'm asking, who was that?
That's me.
Okay. Who's
Sydney.
me? Okay,
Sorry,
Sydney.
Sydney.
That's all right. First things first, Sydney. What is pH doing in this situation?
It's alkalosis.
It's 7.4. What is that?
Oh, normal.
There you go. Normal. What is CO2 doing, Sydney?
That's alkalosis. No, acidosis. I don't.
Look at your range. Right? 35 to 45. Anything greater than 45 is acidosis. Anything less than 35 is alkalosis. Anything in
Okay.
between is normal. So it's 36. So what does that mean?
It's alkalosis.
Oh,
It's normal. See, anything in between those ranges is normal.
Oh, okay. But I thought it had to lean towards one.
no, listen. I told you pH is the only one that leans.
Okay, okay.
The other ones, if they're in the normal range, it's just normal. Okay, so yeah, don't worry about leaning for CO2 or bicarb. The only thing that can lean is pH because it's so wide of a normal range. Okay?
Okay.
You said, let's look at it again. You said pH was normal. A PCO2 of 36 is what, Sydney?
Normal.
There you go, normal. A bicarb of 25 is what, Sydney?
Normal.
Normal. So we have a normal blood gas. Normal. Just a normal blood gas. They're fine. All right. All right, Talicia. pH of 7.2. CO2 of 47 millimeters of mercury. A bicarb of 24. And a PaO2 of 100. So first things first, Talicia, what is pH doing?
It's an acidosis.
We are in an acidosis. Point blank period. Now we got to find out who's causing the problem. So what is CO2 doing, Talicia?
CO2 is high, so it's in acidosis as well.
Acid. What is bicarb doing, Talicia?
Bicarb is 24. It's normal.
So who's causing the problem, Talicia?
CO2 is causing the problem.
So it's a what?
Acid. It's a metabolic.
CO2, aka
respiratory.
there you go.
It's respiratory acidosis.
Respiratory acidosis. Remember, CO2 is respiratory, that's the breathing, right? And bicarb is metabolic. So we're in a respiratory acidosis. All right. Michaelin, you with us?
Yeah, I'm here.
All right. All right, Michaelin. pH of 7.7. A CO2 of 10. And a bicarb of 25. All right. Now, Michaelin, what is pH doing?
pH is alkalosis.
Okay, so we are in an alkalosis. All right, now let's see who's causing the problem. What is CO2 doing right now, Michaelin?
It's alkalosis.
Alkaline. What is bicarb doing?
It's normal.
Normal. So who's causing the problem?
Respiratory
The respiratory
alkalosis.
All right. Kelsey. pH pH of 7.25, CO2 of 40, and a bicarb of 20. First things first, Kelsey, what is pH doing, Kelsey?
Acidosis.
So we are in an acidosis. All right. Let's find out who's causing the problem. What is CO2 doing right now, Kelsey?
It's normal.
It's normal. What is bicarb doing?
Acidosis.
So who's causing the problem?
It's respiratory. No.
Whoever's causing the problem.
Metabolic.
So whoever causing the problem is the one that's matching pH. So pH is acidosis. The only one that's acid is bicarb. So it is a what?
Metabolic.
Metabolic. Metabolic acidosis. All right, I'm a couple more and let you take a break. Get everybody while I can. All right. Lori. pH of 7.3 and a CO2 of 48 and a bicarb of 25. Lori, what is pH doing? So acidosis. All right, now let's see who's causing the problem. What is CO2 doing, Lori? Acid. What is bicarb doing, Lori? Yeah. Normal. So who's causing the problem? Respiratory acidosis. All right, let's take a break and we'll come back and get whoever else wants to go. Make sure I get everybody that wants to go. We're gonna go with Courtney, Kiara, Heather. Oh, I saw Yasmin in here, but I don't see her name anymore. Okay, so let's take a 10-minute break. I'm going to pause right here. We're going to take a 10-minute break. Let's just say it's come back at 3:10. Come back at 3:10. All right, now we're going to talk about compensation and partial compensation. Here it is. A pH of 7.36, a CO2 of 50, and a bicarb of 32. All right. If I look at pH, what is pH doing? Okay.
Normal.
It's normal, but leaning which way?
Acidosis.
There you go. Acidosis. It's normal. We'll put that in there. We know it's in normal range, but it's still leaning acidosis. So let's find out who was causing that problem. So what is CO2 doing?
Acidosis.
Acid. And what's bicarb doing?
Alkalosis.
Alkaline. So who's causing the problem?
Alkaline.
No.
Well, the acidosis, the CO.
The CO2 is causing the problem, right? So we are in a, let me scoot down some. We are in a respiratory acidosis. Okay, now we got to find out, is there compensation? So if the person who's causing the problem is the second player, right? In this case, the other one got to be the third player. Okay, it's only 3 players. So look at your rule. Is the third player in normal range, yes or no?
No.
No. So since he's not in normal range, that means what?
He's compensating.
There is compensation. So we are in a compensated. We're in a compensated respiratory acidosis. Almost done. Now, so that means CO2 was pulling pH into acidosis, right? He has pulled her over to him in acidosis, okay? But bicarb didn't say, well, you can have her. Bicarb said, well, I'm gonna pull back this way. What he's doing is becoming more alkaline, right? Because he's in alkalosis. So since we are in an acid situation, he's trying to make more bicarb to pull us back into the middle, right? Trying to buffer it, like the Rolaids and the pizza, okay? So since respiratory has pulled pH into respiratory acidosis, in this case, bicarb is trying to compensate because he's not in normal range. So he cares. He's compensating, right? So we are in a compensated respiratory acidosis. Now here comes the lean. Was his pulling or his compensation enough to get pH back into the normal range? Yes or no?
Yes.
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 She's in the normal range. She's leaning, but she's still in normal range. So his compensation was enough to pull us back into normal range, right? So that is a fully compensated respiratory acidosis. As hard as it gets, right there. But see, it's some steps involved. You got the basics. Now we got to get into this compensation game. Okay?
How do you know, like, fully or partial though?
Because his compensation was enough to get her back into normal range. 3.6 is in normal range.
Yeah.
So if his pulling was enough to get us back to normal range, we're fully compensated.
Okay.
All right. If he was compensating, but we were still way out of normal range, it would be partially compensated because he didn't get me back into my normal range. Right? Paid some money, but not all your money. Okay. All right. Let's look at some more. pH of 7.43, a CO2 of 20, and a bicarb of 16 milliequivalents per liter. First things first, just like we've been doing, what is pH doing?
That's normal.
There you go. Normal, but what? Alkalosis. See? 4.3, right here. We're normal, but leaning alkaline, right? We're in normal range, but it's leaning alkalosis. Normal, but leaning alkalosis. All right? Now, let's see who the second player is. That's going to be the one that's causing her to lean the way she's doing. He's pulling on her, okay? Well, let's see. What is CO2 doing?
Acidosis. Alkalosis.
There you go. And what's bicarb doing?
Alkalosis. Acidosis.
There you go. Bicarb is 16. That is acidosis. Acid. See that? CO2 is 20. That's alkalosis. Bicarb is 16. He's acid. Okay? Now, let's find out who player 2 is. Player 2 is the one that's matching pH. So which one is causing the problem? Respiratory. That's player 2 again. And so bicarb will have to be player 3. So we are in a what? Respiratory alkalosis. Now we need to deal with the compensation aspect. All right. Now, the third player again is bicarb, right? Is the third player in normal range? Yes or no?
No.
No.
So there is compensation. He's trying to pay something, right? So let's see if he paid it off. So let me scoot down. I don't know why. So we are in a compensated respiratory alkalosis. So we know we have the third player is not in normal range, so we know we have some compensation. He's trying to compensate, right? Now, was his compensation, his pull, was his gain that he was spitting enough to bring pH back into normal range? Yes or no?
Yes.
Yes. So it's what?
Fully compensated.
Fully compensated respiratory alkalosis. All right. Let's look at this one.
So you said if it's player number 3 is out of or it's out of range, then it is compensated.
Yes.
Okay.
All right. pH of 7.36. CO2 of 18. And a bicarb of 16. All right. What is pH doing?
Acidosis.
Say the whole thing.
Normal.
Normal, but in leaning what? Acidosis. She's normal, but leaning acid, right? At 7.36. So she's normal, but still leaning acidosis. Now, let's find out who the second player is in this one. What is CO2 doing right now?
Alkalosis.
Alkaline. Yeah, it's alkaline. What is bicarb doing?
Acid.
Acid. Good. So who's causing the problem this time?
Yeah.
Metabolic.
Yeah.
Listen, who's causing the problem right now?
Bicarb.
Bicarb. You got to say the word bicarb. Bicarb is causing the problem. He's causing the acidosis. So in this case, he's player number 2. And CO2 would be number 3. All right, so we are in a metabolic acidosis. Okay, now let's look at the third player. Is the third player in normal range? Yes or no?
No.
No. So we do have compensation. So we know we have compensated metabolic acidosis. Now, let's look at his game. Was his pull enough to get pH back into normal range?
Yes.
No.
Yes. Who said no?
It's
3.6.
fully compensated because it's back in normal range.
3.6 is still in the normal. Look, guys, 3.5 to 4.5 is normal range, but less than 0.4 or more than 0.4 is when it leans. She's 3.6 right now, so she's right here. That's still in the normal range, but leaning acid. That's why we were in the acidosis. Okay, and so the third player in this case is CO2. CO2 is normal range? No. So there is compensation. He's trying to pay. Okay, so we know we have a compensated metabolic acidosis. But was his pull enough to get pH back into normal range? You said yes. So that's correct. So we are in a fully compensated metabolic acidosis. Now let's look at some partials. Those were all fully compensated. Let's look at some partial compensation. pH of 7.2. CO2 of 52. And a bicarb of 32. Let me ask one at a time. Let's see here. Talisha, what is pH doing, Talisha?
pH is in acidosis.
Acidosis. We ain't even in normal range. 7.2 is way down there. We just simply in a acidosis. Okay? Now let's see who's causing the problem. What is CO2 doing, Lori? So CO2 is acid. Stephanie, what's bicarb doing?
Alkalosis.
Alkaline. All right, so who's causing the problem? Anybody?
Respiratory.
Respiratory, good. So he's the second player because he's causing the problem, and bicarb would have to be the third. So we are in a respiratory acidosis. Now, let's see if we got compensation or not. Is the third player in normal range? Yes or no?
No.
No. So we do have what?
Compensation.
Compensation. So compensated, we are in a compensated respiratory acidosis. Now, was bicarb's pull enough to get pH back into that normal range?
No.
No. No. So that means it's only partially compensated. Partial compensated respiratory acidosis.
So since the pH isn't in normal range, that's when it makes it partial versus full.
Yes.
Okay.
Yes. So we had compensation, but his compensation on his pull wasn't enough to get her back in normal range. So he trying to pull, he just didn't. He trying to pay you money, he just didn't pay you all of it. He only partially paid it. Okay. He tried to get her, but he couldn't get her all the way. He only tried, right? He's partially got her. Or him, however you want to look at it. All right. Let's look at this one. This is another thing you may see. pH of 7.2, CO2 of 60, and a bicarb of 16. What is pH doing?
Acid.
Acidosis. Let's see who's causing the problem. What is CO2 doing?
Acid.
What's bicarb doing?
Acid.
So this means all three of them are acid, right? So that's what you call a combined acidosis. That's all you got to say. It's a combined acidosis. When all three of them are going the same way, it's combined whatever way they're going. All right, let's look at this one. What if I have a pH of 8.0 and a CO2 of 10 and a bicarb of 40?
Alkalosis.
Alkalosis.
Combined alkalosis.
There you go. So pH is alkalosis. The CO2 is alkaline. And the bicarb is alkaline. So that means we are in a combined alkalosis. All right. See if anybody came back. It's Winston. Okay. Yasmin, can you talk?
Yes.
Okay. Let's look at this one. Okay, Yasmin, I got a pH of 7.38, a CO2 of 40, and a bicarb of 18. So Yasmin, what is my pH doing?
Acidosis.
It's leaning acid, but it's still what? It's still in normal range, so it's
Alkaline.
no. It's normal, but leaning.
Normal acidosis.
In the parentheses, the 3A is still in,
Acidosis.
but we are normal but leaning acidosis, right? Good. Now let's see who's causing the problem, Yasmin. Yasmin, what is CO2 doing? What is CO2 doing?
Acidosis.
Right here, CO2 normal range, 35 to 45. So 40 is the number.
Acidosis.
Oh.
Yeah.
35 to 45 is your normal range for CO2. It's 40.
Right.
So it's right in the middle. So it's normal.
So
Okay?
normal acidosis?
No.
No, it'll just be normal.
It's just normal.
Okay.
Yeah. Yasmin, the CO2 and the bicarb don't lean. Only the pH can lean. Okay.
Okay.
Only the pH will ever be normal, but leaning some way. Okay. So I see what you were thinking. But no, CO2, if it's in the normal range, it's straight up normal.
Okay.
If bicarb is within that normal range, it's straight up normal. Okay. It don't lean. So 7.38 is normal range, but leaning acidosis for pH, because pH does lean. That's the only one that leans. So CO2 is 40. So what is that, Yasmin? CO2 is 40. So what would that be? You with me?
Normal.
Yeah, normal. So CO2 of 40 is normal. It's in between 35 and 45, 40 being smack dab in the middle is normal. All right, now, Yasmin, look at the bicarb. What is the bicarb doing, Yasmin? What is the bicarb doing?
Normal.
These are the numbers for bicarb right here. 22 to 26. Less than 22 is acid. Greater than 26 is alkalosis. So bicarb is 18. Huh? Bicarb of 18. What would that make it? It's okay. Just tell me what is 18. Look at the 18 right here. Is 18 less than 22? Huh?
Acidosis.
Acidosis. Acid.
Acidosis.
Yes. Bicarb is in acidosis right now because it's 18. 18 is less than 22. Anything less than 22 for bicarb is acid. Anything greater than 26 for bicarb will be alkaline. Okay, these are the normal ranges right here. So,
yes.
Kind of breaking up a little bit. So we are in the acidosis. Now let's find out who causing the problem. Kelsey, who's causing the problem? Kelsey, I can't hear you.
Hold on. Bicarb?
Bicarb, because bicarb is matching the acidosis. So bicarb is the second player in this case, and PCO2 will be the third player. So
it's respiratory.
if bicarb is causing the problem, What is it, Kelsey?
I mean, metabolic. I'm sorry. I keep saying that.
Yes. It's acidosis.
Metabolic acidosis. All right. Now we got to see, is there
My
compensation?
sound keep going now. I'm
Yeah, Jasmine, you
sorry.
breaking up bad.
Jasmine, you break. Jasmine, you breaking up. You breaking up real bad. We can't understand you at all. Jasmine, you're breaking up really bad. I cannot understand anything you're saying.
I think she logged out and probably gonna log back in.
All right. So we are in a metabolic acidosis. Now let's look at the third player. Courtney, is the third player in normal range?
Yes.
Yes. So since the third player is in normal range, there is no compensation, right? So that's uncompensated. Uncompensated metabolic acidosis. See, only when the third player is not in normal range will you have compensation. And then you got to decide whether it's partial or fully, right? But if the third player is in normal range, then it's straight up uncompensated, whatever it is. Okay? All right, Jasmine, you were breaking up real bad now.
I know, because I was trying to answer, but my computer kept going in and out.
Oh, okay. All right, so let's look at this one then, Jasmine. If I have a pH of 7.1 and a CO2 of 50 and a bicarb of 24, Jasmine, what's going on? Let's see. First things first, check pH first. What is pH doing, Jasmine?
Acidosis.
Okay, so we're in an acidosis. Acidosis. Right, good. pH is 7.35 to 45. Anything less than that is acidosis. Okay. All right. Now we got to find out who's causing the problem. Whoever is matching pH is the one that's causing the problem, Yas. Okay. So let's look at each one. CO2 in this case is what, Yas?
Acidosis.
Acid, good.
Acid, yeah.
And bicarb is what?
Normal.
Good. So who causing the problem, Yasmin? Who's the one matching the pH?
The
pH is acid, CO2 is acid, bicarb is normal. So which one is matching? CO2. So if it's a CO2 problem, it's a what problem? Not metabolic. Remember your AKA CO2, AKA ventilation, AKA respiratory, AKA acid, right? So if respiratory, I mean, if CO2 is causing the problem, then it's a respiratory issue.
Okay.
Okay, so respiratory acidosis. Okay, now let's look at the third player. So since CO2 is causing the problem, he is the second player. And bicarb will be the third player. All right. So Yasmin, let's look at the third player. Do you have the rules, Yasmin?
No.
Okay. So just listen up then. All right. Shatara. Do you have the rules, Shatara?
The rules?
Yeah, when I had my rules for solving ABGs.
Yes, sir. The 3 rules?
Yes.
I got them.
Okay, so rule number 3 says, is the third player in normal range? Yes or no?
Yes.
Yes. So the third player is in normal range. So that means it's not trying to compensate, right? If the third player is in normal range, there is no compensation. So you can say uncompensated respiratory acidosis. All right. Now, I'm going to put one up here. I want you to tell me what it is in the chat. pH of 7.43, CO2 of 51, bicarb of 30. I want you to tell me what that is. All of it. The compensation, the partially, unpartial, all of that. What it is in the chat. Those same rules that I put up there, guys, are also in the module. One of those pictures in this module that has all the rules and all this I just put is already in there. So you can look at that if you need to for the rules. Like I said, this is hard as the ABGs get. It's the fact of just knowing what unit is what and which way is, is acid or not. Then you can know how to interpret ABGs. The oxygenation part is simple. Once we get to that, that's simple. And when you get on to 220, you'll learn how to manage ABGs. What do we do to fix them? So let me look at it. That is a all right, Kelsey. You almost got it, Kelsey. You got the wrong player. Michaelin, good. Christian, okay, you got metabolic, but finish the rest of it, Christian. I need the whole thing. Talisha, you're right, but specify that compensating. Specify that for me. What kind of compensating? Is it partial or is it fully? Charisma, good. Talisha, good. You got it. Good, Kelsey, that's better. Did you put something in there yet? Michael, let's see. Stephanie, good. Kenya, good. Heather, good. Lori, good. Okay. Shatara, good. Yasmin, look at it again. Since you don't have the rules, it's probably be harder for you to do it, but I'm gonna show it to you in a minute.
Yasmin, I direct message you the rules. I don't know if you can see them or not.
Brittany, let me see. Brittany,
No, I'm about to open it.
Brittany, you almost got it. You need to tell me what.
Okay, I see it. Thank you, Charisma.
You didn't finish it, Brittany. Brittany, you didn't finish it. You're almost there, Brittany, but you didn't finish it. All right, so let's look at it. pH in this case is 7.43. That is normal but leaning alkaline. Alkalosis. Normal but leaning alkalosis. Let's see who's causing the problem. CO2 is 51. That's acid. He ain't causing the problem. Bicarb is 30. That's alkaline. Oh, he's the one causing the problem. So he is the second player, and CO2 is the third player. Now, I know I am, since he's the second player, I know I'm in a metabolic alkalosis. Now, I need to look at my compensation. My third player, is he in normal range? No. So I know I have compensation. So I know I'm in a compensated metabolic alkalosis. Now, was CO2's game or was his pull enough to pull pH back into normal status? Yes. So it is fully compensated metabolic alkalosis. If you got that, you're on your way. All right, let's look one more, then we'll take another break in a minute. Ooh. All right, pH of 7.35, CO2 of 58, and a bicarb of 30. Work on that one. Yasmin, when you look at the rules, you just follow those rules. Number 1, you go down number 2, and then number 3.
Do you want us to put it in the chat?
Yeah. All right, let me see what I'm looking like. All right. Shakara, look at it again. You almost there, but you got the wrong player. Look at your players again. Who's causing the problem, Shakara? Find out who's causing the problem. That's going to be your player, okay? Stephanie, good. Brittany, you You just got one thing. You got alkalosis. I mean, that go ahead and tell me the whole thing, Brittany, unless you were answering that other question. Kenya. Okay. What are we in though, Kenya? I mean, you got it. You got the compensation part and who's the problem, but where they at? What land are they in? Are they in acidosis or are they in alkalosis? You got to tell me the whole thing. Charisma, good. Heather, good. Michaeline, good. Talisha, good. Brittany, good. Brittany, look at it again, Brittany. You got the first part right, but the state that we're in is not right. What is pH doing? What is pH doing? That's what you need to look at. All right, Lori, good. Shatara, good. Courtney, good. Christian. No, you can't have alkalosis and acidosis in the same problem, Miss Christian. It's either or. But we're gonna look at it. I'm gonna let you work it with me in a minute. All right, so let's look at it. This is, let's see, Christian. Christian, what is?
I'm here.
What is pH doing, Christian?
Acidosis.
Acidosis, but is it in normal range?
Yeah.
Yeah, so it's normal, but leaning acidosis.
Mm-hmm.
Don't forget, pH is the only one that can lean. All right? All right. So now we have to find out, Christian, who's causing this problem. So in this problem, CO2 is doing what?
Alkalosis. No, hold on. Acidosis.
Acid. So CO2 is acid. And what's bicarb, Christian?
Alkalosis.
Alkaline. All right. So which one is matching pH? pH is
PaCO2.
there you go. CO2 is causing the problem. Whoever's matching pH is the one that's causing the problem. All right.
Okay.
So CO2 is the one that's matching pH. So it's a CO2 problem. So if the CO2 is causing the problem, what do we call that?
Metabolic.
Metabolic. Remember, AKA CO2, AKA.
Oh, respiratory ventilation.
Respiratory. If the CO2 is causing the problem, it's a respiratory issue. Okay, because CO2 is ventilation. It's the lungs. It's a respiratory issue. Okay, so we are in a respiratory acidosis. Okay, now, since that's the case, that means he's the second player and bicarb is the third player in this case. So, Christian, if we look at number 3, it says the third player. Is the third player in normal range, yes or no?
No.
No. So since it's not, we do have compensation. So it's compensated respiratory acidosis right now.
So if it's fully compensated, then it's not normal. If it's not normal, then it's fully compensated?
No, if the third player is not in normal range, then there's compensation. But we don't know if it's fully or not until we look back at the pH.
Okay.
Right? So the first thing to do is
Hey, Jazz, I directed message you to explain how to get it too.
The first thing you got to do is to listen up. The first thing to do is on the third player. Is the third player in normal range? Yes or no? You said no. So that means we are in a compensated situation. Compensated respiratory acidosis. Now we can find out if it's fully or partially, Christian, by looking back at the pH. Now, so looking at that rule, it said was the player 3, was his pull enough to get pH back into normal range? Yes or no? 735 to 745. It's 35. So is that in normal range?
Yes.
Yes. So because that's what we said from the get-go. We said pH was in normal range, but leaning acid. And so then we said, well, who's causing her to lean that way? We said, oh, it's CO2 because CO2 is the one that's acid. Bicarb in this case was alkaline. So it's a respiratory acidosis. Then we looked at the third rule, which says, look at your third player. Is the third player in normal range? You said no. So if it's not in normal range, then there is compensation. So that's a compensated respiratory acidosis. Okay. And then we say, okay, was his pull on the other end of the range, right? Was his pull enough to pull pH back into normal range? We already said yes. So that means it is fully compensated respiratory acidosis. You see that, Christian?
Yes, I see it.
Okay. All right, well, Christian, let's do one more. All right, Christian, pH of 7.42, CO2 of 51, and a bicarb of 36. All right, Christian, first things first. What is pH doing in this case, Christian?
Alkalosis.
Alkalosis. But is it in normal range?
Yeah.
Yes, I always say that first. Say normal but leaning alkalosis. So say that.
Normal but leaning alkalosis.
Good. Excellent. Because 7.42 is right here. It's still within my normal range. Right? From 7.35 all the way to 4.5 is normal range. But past 4 is leaning alkaline and less than 4 is leaning acid. Okay? So she is 4.2. So 4.2 is right here. That's normal, but leaning alkalosis, like you said, alkalosis. Excellent, Christian. Excellent. All right. Next thing to do is say, who causing this problem? Which one of them is in her ear pulling her to alkalosis? All right. Let's see. What is CO2 doing right now, Christian?
Acidosis.
Acidosis. Because CO2 is 51, so that's greater than 45, acid. All right, so he's acid. So we know he ain't causing a problem because he's not matching her. All right, so let's see what bicarb is doing. What is bicarb doing, Christian?
Alkalosis.
Alkalosis. Good. Now, which one causing the problem then?
What's that? CO2?
And that's called, it's HCO2.
Bicarb.
That's bicarb. So bicarb is causing the problem. So he is the second player. And that means CO2 will have to be the third player. Okay? Now, since we know that bicarb is causing the problem, what type of alkalosis are we in since it's him?
Respiratory.
Respiratory is CO2.
Oh, metabolic.
There you go. Metabolic. Don't forget, bicarb, aka metabolic. CO2, aka respiratory. Right?
Okay.
So since bicarb is causing the problem, it's a metabolic issue. So you're excellent. You're absolutely right. Metabolic alkalosis. Good. Now, let's look at the last part of this. Rule number 3. Is my third player in normal range? Yes or no? Is this in normal range for CO2?
No.
No. So if it's not in normal range, that means what, Christian?
It's not normal.
Yeah, don't you have the rules?
Not up on my screen right now. I ain't got it up with me right now.
Is it a compensated?
Yes, if the third player, Christian, if the third player is not in normal range, that means you do have compensation.
Okay.
y'all? If the third player is not in normal range, that means you do have compensation. He's trying to compensate, right? He done got out of normal range and all hot under the collar because he's trying to compensate for this situation. If the third player is in normal range, then he don't care, and there's no compensation. Okay. All right. So the third player is not in normal range, right? 51, that's not normal range. So we do have compensation. So let me scoot it down. We have a compensated what I say? Metabolic alkalosis. Good. We have a compensated metabolic alkalosis. Okay, so Christian, was CO2's pull his compensation? Was it enough to pull pH back into normal range?
Yes.
Yes. So that means it's what kind of compensated, Christian?
Normal.
Fully. Full.
Oh, fully. Okay.
Make sure you study those rules. If the third player, if his pull was enough to pull pH back into normal range, which we said from the get-go, that means it's fully compensated. If his pull was not enough to get her back into normal range, it would only be partially compensated. Okay? All right. Make sure y'all look at this tape and study and practice. All right, because now we got to look at the oxygenation part. Let's take your break. All right, 4:15. Come back at 4:25. Like a 10-minute break. We're going to come back and do the oxygenation component now. All right, guys. So let's get back to the aspect of the second component of the ABG. Ventilation and oxygenation are two different things. You have just learned how to interpret the blood acid-base status of the blood. The acid base, whether it's a acidosis or alkalosis, and whether metabolic is the issue or if it is respiratory. But now we have that second component that we have to add to it, and that is the oxygenation status. Okay, we learned that hypoxemia is a deficiency of oxygen in arterial blood, right? And we said hypoxia is lack of oxygen in the tissues, right? All right, so let's look at how much is what and what we're looking for. The normal value for the PaO2 is 80 to 100 millimeters of mercury. 80 to 100 is the normal PaO2. If it's 80 to 100, there is no hypoxemia or just normal oxemia. Okay, normal, right? So I'm going to show you when it's not normal. So I'm going to share my screen so you can write this down. Look right here at the assessment of hypoxemia. Here it is right here. On room air, the normal PaO2 is 80 to 100. Now remember, that's on room air because, of course, if they were getting more oxygen, it would be more than that. But on room air, the normal PaO2, which is the partial pressure of arterial oxygen, is 80 to 100. All right? Anything less than that starts to become hypoxemia. All right? So mild hypoxemia is 79 to 60 millimeters of mercury. That is mild. Then moderate hypoxemia is 59 to 40. And then severe is anything less than 40 millimeters of mercury. And that's it for the hypoxemia as far as the P little AO2 is concerned. All right. So here it is on the board, because you see that there's other ways to do it by the total O2 content, but we're going to talk about that in a minute. One thing at a time. Here it is. P little AO2, which is right here in your ABG. That's part of your ABG. Okay, that's the oxygenation status part. 80 to 100 is normal oxemia. Normal oxemia. Okay. If it is between 79 and 60, then it's mild. It's just mild hypoxemia. Moderate is 59 to 40 millimeters of mercury. If that P little AO2 is 59 to 40, then it's moderately hypoxic. And anything less than 40 is considered severe. Anything less than, not 40, 40 is moderate. Less than 40 is severe. All right. So write that down so I can move it and I can do some more ABGs and I can start to add the oxygenation component to it. All right, everybody got it wrote down? What? Hypoxemia is the blood and hypoxia is the tissue. All right, so let's look at some and add the oxygenation status with it. So this is when you say respiratory acidosis with normal oxemia, or with mild hypoxemia, or with severe hypoxemia, okay? That's what you do. All right, here we go. pH of 7.2, CO2 of 58, bicarb of 24, and a P little AO2 of 85. First things first, Charisma, you with me?
I'm with you.
Okay, pH of 7.2. What is the pH doing, Charisma?
It's acidosis.
Acidosis. So we are in an acidosis. Okay. Now let's find out who's causing the problem. So pH, we're in an acidosis. Now, what is CO2 doing, Charisma?
Acidosis.
Acid. What is bicarb doing, Charisma?
Normal.
Normal. Okay. And what is PaO2 doing?
It is normal oxemia.
Normal. All right. So, and this, like I say, this is separate. All right. Now, the acid-base status is this part. We are in an acidosis. So, which one is causing the problem, Charisma?
The CO.
CO2. So, CO2 is the second player, and the bicarb is the third player. Now, make sure you don't say CO, because CO is carbon monoxide. Okay? So, since PaCO2 is causing the problem, Charisma, what kind of acidosis are we in?
Respiratory.
Respiratory acidosis. Now, let's look at the third player, Charisma. Is my third player in normal range?
It is, so it's uncompensated.
So it's uncompensated respiratory acidosis with what?
Normal oxemia.
Normal oxemia. That's it. That's it. All right. Michael, you with me?
Yeah, I'm here.
Yours, Michael. pH of 7.8, CO2 of 10, and a bicarb of 16. KO2 of 35. Hey, Michaelin, what is the pH doing?
The pH is alkaline, alkalosis.
Alkalosis. All right, let's see who's causing the problem. What is CO2 doing, Michaelin?
It's alkalosis.
Okay, alkalosis. What is bicarb doing, Michaelin?
It's acid.
Acid. So who's causing the problem, Michaelin?
It's going to be respiratory alkalosis, and it's going to be partially compensated.
Excellent. So respiratory alkalosis, one at a time so everybody can understand. Respiratory alkalosis. So that means he's the second player, and this is the third player. Michaelin is the third player in normal range.
No.
No, so that means we do have compensation. So we have a compensated respiratory alkalosis. Now, Michaelin, was bicarb's compensation enough to pull pH back into normal range?
No, it wasn't.
No, so that means it's what?
Partially.
Partially. Partially compensated respiratory alkalosis, and Michaelin with what type of oxygenation?
Severe oxemia.
Severe, so it's severe hypoxemia.
Hypoxemia. Oh, my
There
bad.
you go. Severe hypoxemia.
Mama.
That's it. Now that's all of the ABG, as hard as an ABG will get. As hard as it gets. So that's how you got to be able to read them. Just like that. Because once I get that information, that's what's going to make me determine how do I fix the problem. Okay? How do I fix the problem? Because if it's a respiratory issue or CO2 issue, I will fix it with the ventilation because CO2 is ventilation. I'm either going to make them blow some more off or stop blowing so much off. If it's an oxygenation problem, I'll fix it by giving oxygen. All right? All right. Let's see here. A couple more. Let's see. Lori. pH of 7.41, CO2 of 10, and a bicarb of, wait a minute, I think I just had that one. Let's do a CO2 of, let's do the pH of 7.41, CO2 of 65, and a bicarb of 29, and a PaO2 of 75. All right. Lori, what is pH doing? Normal, but leaning alkalosis. All right. Now, What is, see who the second player is. What is CO2 doing, Lori? Acid. What is bicarb doing, Lori? Alkaline, okay. And then what is the PaO2? Mild hypox, right? All right. So since who's causing the problem, Lori? Bicarb is causing the problem. So he's the second player, and CO2 is the third player. So since bicarb is causing the problem, what kind of alkalosis are we in? Metabolic alkalosis, right? All right. And now let's look at the third player, Lori. The third player is CO2. Is the third player in normal range? No. So there is compensation. So compensated metabolic alkalosis. Now, was CO2's pull enough to pull pH into normal range? Yes. So it's fully compensated metabolic alkalosis with mild hypoxemia. Everybody understand? Anybody don't understand? You got to practice it. I'll give you some practice ones to do, and we can go over them the next day, stuff like that. But if you don't understand the concepts, you need to let me know so we can work them. Because if you don't know the concept, now you could be like, you know, oh, I meant to put that and I meant to put that. That's okay. We're just learning. But if you don't, I don't have no clue what you're doing. If you're in that boat, you need to let me know. Okay. And it's okay to not know. This is the hardest part of respiratory is ABGs and management of ABGs. So don't feel ashamed now and then don't say nothing, and then you get to the test and don't even have a clue. Because now, as we go forward, since ABGs are so important, you will have 1 or 2 ABGs on every single test going forward. So not only this test, but the next module, you'll have 1 or 2 sprinkled in there. The next module, 1 or 2 sprinkled in there, because you've got to be able to keep that. Because when they give you these oral exam and they pull up this card and say, what is this ABG? You got to know how to do it. And it's going to be 5 of them. It may not be 5, but it should be at least 5. We work on that. You might, one person might not have 5, but, you know, be expecting to see possible at least 5 ABGs on the oral. And it's only 20 questions, and you can only miss 5 to pass it. So if you don't know ABGs, you're going to fail it. Okay? You're going to fail it. And we do that because it's so very important to understand these going forward. Well, you only get 20 questions. All right. So that is acid-base status, guys. That's acid-base status and oxygenation. You got whatever with, and then we talk about the oxygen. Okay. Now, when it comes to hypoxemia, you just learn what the levels are for P little AO2, but there's also some levels for total O2 content that also mean hypoxia, which is mild, moderate, or severe. But we'll get to that one a little later. Okay. Let's go on with the lecture, and I want to show you a video. Now, this video, I'm going to have to stop the recording for the video because it's a YouTube video that is very detailed about ABGs. So you can go back and look at it because the video is in the module. So you can go look at it yourself, you know, when you get home, but I just can't record it. All right, so I'm going to cut it on. We're going to watch it, kind of go over some questions together. I may stop and say, what is that? What is this? Okay. He kind of breaks it down. Similar to how I do it. Nobody's like me, but no, I'm just playing. He breaks it down really well. He's a nurse. That's why I'm messing with him. He's a nurse, not a respiratory therapist, so you know, we'll take it with a grain of salt. But I looked at it, it's good. All right, so let's look at it together. Stop the record. Okay, guys, we had looked at some of the video. We stopped. We're going to stop at this point here. Finish up some more of the video tomorrow. The homework tonight is homework number 3. I want you to do homework number 3 tonight for homework. Okay. Homework number 3, which talks about the dissolved O2 and combined O2 and calculating dissolved, combined, total. Then you have to do the alveolar equation and the Aaa gradient. See that? All of them are there. They want to know what's dissolved, how much is combined, what's the total, and then the P big AO2 is your alveolar equation, and then tell me the Aaa gradient. Okay? Tell me the Aaa gradient using the values they give you. They give you the, you know, depending on what they give you. Like one of them give you the hemoglobin, they give you the P little AO2, they give you the PCO2, FiO2, the SAT, the barometric pressure. PB, guys, is barometric pressure. PB is barometric pressure. They give you the respiratory quotient. If they don't give you the water pressure is 47. Okay, so use what they give you and calculate all, and don't forget those formulas. Dissolve was 0.003 times P little AO2, and then combined was the 1.34 times the hemoglobin times the SAT. Don't forget, the SAT must be written as a decimal. And then, of course, your total is when you add those two formulas together. Your P big AO2 is the alveolar equation that we did. Don't forget, the FiO2 is as a decimal. And then the Aa gradient is when you take the alveolar air tension and subtract the arterial tension from it. Big A minus the little a, and that's your Aa gradient. Okay, that's homework for tonight. Just number 3. Due by midnight. Okay, by midnight. Even if you don't get to see a lot of this video, everything on this homework was done yesterday. Okay, so nothing, you know, pretty much not much did you cover anything on here today. So all of this can be done right now from what you've learned. All right, so because it usually sometimes been taking a while to load these lectures because they're getting longer and it just takes a while. But either way it goes, that's for homework tonight. Study what we went over. When you do get the video, study it. Try to come to class. I still only have one student coming to class. And just FYI, they're getting ready to start merging back to on campus with these vaccinations and all that kind of stuff. They're about to start moving back on campus. Students are going to start being held to higher attendance and participation standards. So start getting yourself ready for that, especially when you go to clinicals next time. You got to be there every day. I don't know how some of you working are going to be able to work around that. But hey, that's a little bit down the road. So that's the homework for tonight. I'll see you guys tomorrow at 1. Anybody that wants to come can come because I don't never have enough to say no. So you need to be here. All right. Have a good day.